Welcome to our live stream. Tonight I will be doing a review session preparing us for our exam. Third exam is Monday night at 6 o'clock, and I hope you find this useful. So what I sent in the previous email was an old exam used in the previous semester. We've had a chance to work on a couple of those problems, but if not, that's okay too. You can always work on them later. But I'm going to get started by looking at our first problem. And what does that say? That says that sine of theta is 3/5. And we are also told that theta is between pi over 2 and pi. So that's important for us to remember what we're dealing with. What quadrant are we located in? And I apologize for the lack of focus. And here it comes. What quadrant are we in? We are more than pi over 2, and we are less than pi. Here's pi over 2. Here's pi. So theta is somewhere in that region. And in that region, what can we say? We can say that we're in quadrant 2. In quadrant 2, sine is positive, but we want cosine. Cosine theta is negative in quadrant 2. So that's the first thing I've got to find. I've got to find out what cosine theta is. So let's remember our favorite identity. Cos squared theta plus sine squared theta is 1. I've told you that sine theta is 3/5. So I get cos squared theta plus sine squared 3/5 squared is 1. Cos squared theta plus 9/25 is 1. Subtracting 9/25 from both sides, I get cos squared theta is 1 minus 9/25, or cos squared theta is 16/25. Now again, remember, we said theta is between pi over 2 and pi. Theta is in quadrant 2. In quadrant 2, cosine is negative. So knowing that, we're going to say cosine theta. Normally we say plus or minus, but this time we want minus the square root of 16/25. So what will that give us? We'll have to say that cosine theta is negative 4/5. So that was the first question that was asked. The next question that was asked in this discussion was to find sine of 2 theta. Sine of 2 theta. Now think about this. Theta is between pi over 2 and pi. So 2 theta would be between pi and 2 pi. 2 theta is down here in either quadrant 3 or quadrant 4. So that should tell us something about the sign, S-I-G-N, of sine 2 theta. Of course, it should be negative. So sine of 2 theta is 2 sine theta cosine theta. Well, we know what sine theta is. Sine theta is up here. So we get sine of 2 theta is 2 times sine of theta is 3/5 times cosine of theta is negative 4/5. We put all this together. 2 times 3 is 6 times negative 4. Negative 24 over 5 times 5 over 25. That's our second answer to that question. And then the third part of our question is going to be to find tangent of theta over 2. There are several different formulas you can use for tangent theta over 2. I'm going to choose to use 1 minus cos theta over sine theta. 1 minus cos theta over sine theta. So again, we know what cos theta is. Cos theta is here. We know what sine theta is. Sine theta is there. So that's enough for us to finish this problem. Tangent of theta over 2 is 1 minus cos theta. Cos theta is negative 4/5 over sine theta, which is 3/5. So we get tangent of theta over 2 is 1 plus 4/5 over 3/5. 1 plus 4/5, 5 plus 4, 9/5 over 3/5. And if you like, we can go ahead and do division of fractions. So tangent of theta over 2 is 9/5 divided by 3/5. which is 9/5 times 5/3. And the answer for that is 3. So really the only tricky part about this problem, let's go back and look at the very beginning one more time. And that is me telling you that theta is more than pi over 2 and less than pi. So that tells us then that theta is in quadrant 2, more than pi over 2, less than pi. And if that's the case, in quadrant 2, cosine of theta is negative. So when I got to this part, right, when I got to this part, I have cos squared theta was 16/25. Knowing that cosine is negative in the second quadrant, I have to go ahead and say cosine theta is minus square root of 16/25. Cosine theta is minus 4/5. So I hope that was fairly easy for us to follow. The next question we're going to look at requires us to make some sense out of the identities. So let me go ahead and write that question next. So, and here we go with our focus problems. Let's see if it'll focus on the pen. If not, it'll focus once I start writing. So I've got tangent of 65 degrees minus tangent of 20 degrees upstairs. Tangent of 65 degrees minus tangent of 20 degrees divided by 1 plus tangent 65 degrees, tangent 20 degrees. So this will require me to use some sort of an identity. So I have to look on my identity sheet to see which one makes sense here. And you're looking for tan A minus tan B on the top, 1 plus tan A tan B on the bottom. So if that's the case, I am using the following identity. Looking at my identity sheet, I find tangent of A minus B equals tangent A minus tangent B over 1 plus tangent A tangent B. So writing the right-hand side there, tangent 65 comes first, minus tangent 20 comes second. So knowing that, it appears as if A is going to be 65 degrees and B is going to be 20 degrees. On the bottom, I will say 1 plus, you can see tangent 65. 65 is supposed to be A, it is. Tangent 20, tangent is supposed to be B. So if that's the case, what I have on the left here is tangent A minus B, tangent 65 degrees minus 20 degrees equals all that. So therefore, all of this then equals tangent of 45 degrees, which I really hope you know what that is. Tangent of 45 degrees is 1. So before we go on with the review problems, let me quickly remind you of the basic trig functions that we need to use for our favorite angles. So let's quickly go ahead and do that. Just a quick reminder, we always start with a unit circle. This is 1, 0, 0, 1, negative 1, 0, 0, negative 1. That's what we start with. And all those also correspond to radian measure or degree measure. But in calculus, we almost exclusively use radian measure, so that's 0 radians. This is pi over 2. That's pi. That's 3 pi over 2. And that's 2 pi. So if we have our unit circle angles being 0, pi over 2, pi, 3 pi over 2, 2 pi, cosine value is x, sine value is y. Cosine value is x, sine value is y. So looking at 0, the x value is 1. X value is 1, y value is 0. Looking at pi over 2, x value is 0, y value is 1. Looking at pi, x value is negative 1, y value is 0. Looking at 3 pi over 2, also negative pi over 2, by the way. X value cosine is 0, y value sine is negative 1. 2 pi will be the same as 0, x value is 1, and y value is 0. So those are the trig functions we get directly off the unit circle. But then we also want to get the ones that correspond to 30, 45, and 60 degrees. So let's quickly look at those. 30 degrees, 45 degrees, and 60 degrees. And for fun, we can add 0 degrees on top. We could add 90 degrees on the bottom. I like to do radians first. Radians here, 0. Radians here, pi over 6. Pi over 4. Pi over 3. You can't quite see that, so I'll move it down. Pi over 2. I like to do sine first here. Sine of 0 is 0. Sine of pi over 6 is a half. Sine of pi over 4 is 1 over root 2, or root 2 over 2. Sine of 60 is root 3 over 2, and sine of 90, which is pi over 2, of course, is 1. And then to do cosine, we just write it from the bottom. So we start at 1, then root 3 over 2, then 1 over root 2, then 1/2, then 0. So my suggestion before any exam that uses these things is build these two tables so that you don't have to think about it too much when you're asked to do the evaluation. Okay, so those are our basic facts, the facts that we want to know when we are doing this analysis. So let's go ahead and jump to our next question, which is the tangent of pi over 12. Let's take a look at that. What does the tangent of pi over 12 look like? As I try to get this paper centered nicely. Tangent of pi over 12. Now, you might be able to do this as a subtraction question, but I think it makes more sense to do a half angle argument. So the identity that I'm going to want to use will be tangent of theta divided by 2 is 1 minus cos theta over sine theta. Now, I need to somehow get tangent pi over 12. So pi over 12 is half of something. Pi over 12 is half of pi over 6. So I'm going to say tangent pi over 6 divided by 2. So if that's the case, I am using pi over 6 here is standing in for theta there. Therefore, my answer will be 1 minus the cosine of pi over 6 divided by the sine of pi over 6. Well, what is the cosine of pi over 6? That's the same thing as the sine of pi over 3, root 3 over 2. 1 minus the square root of root 3 over 2 divided by a half. Now, this answer is correct. It's not wrong. It's just not finished. We don't usually like fractions on top of fractions. So during the exam, you're going to often ask, is it good enough? So, I mean, we don't concern ourselves too much with things like rationalizing denominators, but we really don't want fractions on fractions. So here's what I'm going to do. I'm going to multiply the top by 2 and the bottom by 2. 2 times 1 is 2 minus 2 times root 3 over 2, root 3, divided by 2 times a half, which is 1. So that my answer for this is 2 minus the square root of 3. So the tangent of pi over 12 gives us 2 minus the square root of 3 if we use this formula. Now, you have many, many formulas for tangent of theta divided by 2. So it depends on where we get. Can I explain the pi over 6? Sure, Ulissa, I will try. So the question is pi over 12. And this is what I'm thinking. I'm thinking I want to use a half angle. I might have done subtraction, but I want to say pi over 12 is half of what? That's what I'm thinking about, because I'm thinking that the pi over 12 is going to give us a half angle argument. So if I rewrite that as an algebra question, I could say pi over 12 is 1/2 times x. At this point, I have to multiply both sides by 2 to solve for x. Multiply the left side by 2, multiply the right side by 2. So on the right side, 2 times a half, I just get 1x. On the left-hand side, I get 2 over 1 times pi over 12. You reduce the fraction, and you get pi over 6. So indeed, pi over 12 is half of pi over 6. So I rewrote pi over 12 as pi over 6 divided by 2. And then I use this formula, 1 minus cos theta over sine theta, 1 minus cos pi over 6 over sine pi over 6. So yeah, that's a little tricky. I hope that clarifies things. But indeed, if you have more questions, feel free to put them in the comments, and I'll make every effort to get to them. Okay, our next question is a challenging one. I think the next question may be the most challenging question in this unit. So we're solving an equation. The equation we're solving is sine 6 theta plus sine 4 theta is 0. And I'd like that to focus. Will it focus for me? There we go. Maybe not. Let's put the pen back. Let's see if it'll focus now. That's a little better. So we'll leave a pen on the paper to keep it focused. I have to use an identity to do this. So this is a sum, sine 6 theta plus sine 4 theta. That is a sum. I would like to turn that sum into a product because then I can appeal to the zero property of products. So here is the identity that I want to use. I want to use the identity sine A plus sine B equals 2 times sine A plus B over 2 times cosine A minus B over 2. You are not expected to memorize the sum to product identities. They will be given to you on the exam. Now, I hope it's obvious in our problem here that A corresponds to 6 theta and B corresponds to 4 theta. So we're going to rewrite this using that fact. So I will say sine of 6 theta plus sine of 4 theta equals 2 times the sine of A, 6 theta, plus B, 4 theta divided by 2, times cosine A, 6 theta, minus B, minus 4 theta, divided by 2. So we get sine 6 theta plus sine 4 theta equals 2 times the sine of 6 theta plus 4 theta, 10 theta divided by 2, times the cosine 6 theta minus 4 theta, 2 theta divided by 2. Continuing with this, we'll say sine 6 theta plus sine 4 theta equals 2 times 10 theta divided by 2, 2 times sine 5 theta times cosine 2 theta divided by 2 cos theta. So I have successfully rewritten this sum of trig functions into a product of trig functions. Now, why is that important? How does that help us? Let's go back and look at our original question. What was it? It was sine 6 theta plus sine 4 theta is 0. So I can rewrite this as 2 sine 5 theta cos theta equals 0. So that's what this becomes, 2 sine 5 theta cos theta equals 0. We've rewritten the question in a form that will now enable us to solve it. Now, how are we going to do that? We're going to go ahead and recognize that if that's the case, I have this times this equals 0. 2 cannot be 0, so 2 is irrelevant to our discussion. So either sine 5 theta is 0 or cos theta is 0. And we are interested in a general solution. So let me focus on the cos theta is 0 part first. So where is cosine 0? We did our chart earlier. Cosine is 0 here and here. So that means theta is pi over 2 plus 2 pi k, where k is any integer, or down here, that's negative pi over 2 or 3 pi over 2. Theta is 3 pi over 2 plus 2 pi k, where k is any integer. So that half of the problem is done. This half is going to require me to do what? This half is going to require me to say, let w equal 5 theta. And I'm going to say sine of w equals 0. And again, where is sine 0? That's the y value 0 on the unit circle. Y value 0 there and there at 0 and at pi. So I can say w is 0 plus 2 pi k, or w is pi plus 2 pi k. But what is W? What did we say W is? We said W is 5 theta. So replace W with 5 theta. 0 plus 2 pi k is just 2 pi k. Or W is 5 theta is pi plus 2 pi k. Now we have to solve for theta. To solve for theta, I will multiply both sides by 1/5. 1/5 on this side, 1/5 on that side. So I get 1/5 of 5 theta equals 1/5 of 2 pi k. So here I get theta is 2 pi k over 5. Over on this side, same argument. Multiply both sides by 1/5. 1/5 on this side, 1/5 on that side. So we get 1/5 times 5 theta equals 1/5 of pi plus 2 pi k. 1/5 of 5 theta is 1/5 of pi is pi over 5 plus 1/5 of 2 pi k is 2 pi k over 5. So make sure you have all the solutions. We have 4 different pieces. This is a piece. This is a piece. This is a piece. And this is a piece. So in general, we have 4 pieces to our solution set. So let's write them down. I have pi over 2 plus 2 pi k. 3 pi over 2 plus 2 pi k. 2 pi k over 5. Or if you like 0 plus 2 pi k over 5 would be another way to think about that. Pi over 5 plus 2 pi k over 5. And what do we know about k? K is any integer. So that's the solution of that problem. Remember, it started out as sine 6 theta plus sine 4 theta equals 0. So if we go back and look at the argument, what exactly did we have to do there? Let's take a look at it. We started with sine 6 theta plus sine 4 theta is 0. And then we used our identity, sine A plus sine B, and then rewrote it so that I had 2 sine 5 theta times cos theta is 0, and then set each one of those pieces to 0. That's our strategy in a nutshell. Sabrina asks, would you be able to write it as a pi plus 2 pi k all over 5? A pi, I'm not sure what you mean by a, or a pi plus 2 pi k. Sure. I think what Sabrina's asking me is, could I combine these two fractions, pi plus 2 pi k over 5? That would be okay, indeed. Pi plus 2 pi k over 5 would have been acceptable too for that one. All right, let's move to our next question in our list, which will be to prove identities. And I really would like you to follow my strategy for proving identities. Number 1, I think it's better for you in the long run. And number 2, it is much easier for us to grade if we can follow your line of reasoning. So my challenge to you is to do your best to follow my strategy as much as possible for proving trig identities as I try to get this to focus. So here's what we want to prove. We want to prove sine of A plus B. Sine of A plus B over cos A cos B equals tangent A plus tangent B. So here is the strategy I like best. I don't know if your TAs always did it this way, but I think it will serve you well. Always start by writing either left-hand side or right-hand side to start with. I'm going to go with the left-hand side. That is the more complicated side. So the left-hand side is sine of A plus B over cos A cos B. And then we have to think about which identity makes sense, but this sort of tells you, it's telling me I have to use sine of A plus B. So it would be sine A cos B plus cos A sine B. And you, again, you don't have to memorize that. We will give you that identity on the exam. Sine A cos B plus cos A sine B all over cos A cos B. So now this is written as one fraction, so we're going to kind of undo what Sabrina just asked us, rewrite this as a sum of two fractions. So that'll be sine A cos B over cos A cos B plus cos A sine B over cos A cos B. That looks pretty good. And then we ask ourselves what divides out. Cos B divided by cos B is the same thing as 1 over 1. Cos A over cos A is the same as 1 over 1. Those divide out nicely. And then I get sine A over cos A plus sine B over cos B. Sine A over cos A is tangent A. Sine B over cos B is tangent B. And what is that? That is the right-hand side. So that is my preferred strategy for doing complicated proofs. Start on one side, a string of equals, 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 right-hand side. So when all of that is done, we are confident that we have done that correctly, and we are finished with that one. All right, our next problem is sine of pi over 2 plus theta equals cos theta. So we have a sine of a sum. So I believe that also uses the same identity. So we can move this one up a bit. What I want to prove next is I want to prove sine of pi over 2 plus theta equals cosine theta. So we are going to again start with the left-hand side. I'm getting some questions. You don't have to use the product to sum formulas for the bottom one. I'm not sure I know what that means, but no, product to sum was not needed here. Aha, I gotcha. We have a product here, and the thought was, oh, I should rewrite that using a sum. No, that would have made it more complicated. That wouldn't be wrong. That is a true statement. You could use the product to sum, but that is not going to get you closer to your answer. Sabrina asks, do we have to show all that work on the test? My advice on that kind of question is always show more work than you think you need to, because we can give you more partial credit. It will be up to the graders to decide if your work is sufficient. But when in doubt, my advice always is to go ahead and show more work. And we do try to be generous with partial credit. All right, looking at this, we'll go with left-hand side. Left-hand side equals what? Left-hand side equals sine pi over 2 plus theta. And we're going to use the same identity we used before. You see it up here, right? You see sine of A plus B is sine A cos B plus cos A sine B. So sine A, sine pi over 2, cos B, cos theta, sine cos plus cos pi over 2, sine theta. What does that equal? Well, let's remember our unit circle. Pi over 2 is here. What is that point? That point, 0 on x, 1 on y. So sine of pi over 2, sine is the y value, that's 1, times cos theta. You can't see that, so we're going to go ahead and move all that up so you can. Again, unit circle is here. Here's pi over 2. X value is 0. Y value is 1. So the sine is 1. Sine of pi over 2 is 1 times cos theta plus the cos of pi over 2. That's the x value. That's 0 times sine theta. What is that going to give me? 1 times cos theta is cos theta. 0 times sine theta is 0. And that equals the right-hand side, and we're happy again. So yes, I really strongly suggest that you follow my strategy for proving these identities. And I also strongly suggest you to show as much work as possible. The more work that you show, I think, the better we're going to have this. Okay, our next question is about a ladder leaning against a wall. And for the sake of discussion, we'll assume that the wall is a vertical wall. So if you have the paper in front of you, great. If not, I will just sort of summarize what it's asking. We have a 13-foot ladder that hits a light that is 12 feet above the wall. So here's our wall. Here's the ground. We have a 13-foot ladder. So this is 13 feet. This light up here is 12 feet from the ground. So this is the diagram that we're dealing with. And they're defining the angle theta as the angle made with the ladder and the ground away. And they are defining x to be the distance from the ladder. Here's the base of the ladder to the base of the wall. This is x. And the first question they're asking us to find is, well, what is x? Well, I think you can assume that the building is vertical. Knowing that, then this is a right angle. If it's a right angle, we can appeal to the Pythagorean theorem. So we know from Pythagoras that's a squared plus b squared is c squared. In our example, that will be x squared plus 12 squared is 13 squared. So x squared plus 144 is 169, subtracting 144 from both sides. X squared is plus or minus 25. Well, x squared is 25, so x is plus or minus 5. But of course, it's a distance. It has to be positive. So x is 5. So we get that distance from the wall. And you may have memorized that 5, 12, 13 is a Pythagorean triple. Now we want all 6 trig functions. Well, what is the sine of theta? Sine is opposite over hypotenuse. Opposite 12 over hypotenuse 13. Cosecant is reciprocal of sine. So cosecant is 1 over sine. If sine is 12/13, cosecant is 13/12. Next up, we'll go to cosine. Cosine theta is adjacent over hypotenuse, which is what? Here's theta. Adjacent is 5. Hypotenuse is 13. So we get 5 over 13. And secant theta is the reciprocal of cosine. So that would be 13/5. And we have one more. We have tangent. Tangent is opposite over adjacent. Sam's old horse came a-hopping through old Alabama. If we already know the triangle, do we have to show the Pythagorean stuff? I would say probably not. If you recognize that's a Pythagorean triple, I would assume we'd give you the full credit. Tangent of theta is opposite over adjacent. Opposite is 12, adjacent is 5. So tangent of theta is 12/5. Cotangent of theta is reciprocal of tangent. Cotangent of theta is 1 over tan theta. So cotangent theta would be 5/12. Now, the next question that's asked is, what is theta? Well, I said sine theta is 12/13, right? So we've already done that. We know that sine of theta is 12/13. So if we know that, what is theta? Theta would be the inverse sine or arc sine of 12/13, which you can't simplify or you can't evaluate without a calculator. But that's an exact answer. So if I ask for an exact answer, that's the sort of thing I'm looking for. Do we only give the angles with cosine? Do we only give the angles with cosine? Samantha, I'm not sure I understand your question. Only give the angles with cosine. For law of cosines, that's something that we'll see. But yeah, I'm sorry. In this problem, I'm not really sure I understand your question. So I'll keep looking if you get something to us. All right. Our next question is related to law of sines, law of cosines. So maybe that's what Samantha's getting at. Let me go ahead and put this question up on the overhead, and we'll read it together. I'll give you a chance to copy it down if you're doing that in your notes. But again, it's on the PDF that I emailed earlier today. A ship leaves a port sailing due north for 10 miles. So it's going 10 miles due north. They make a course change and turn north 60 degrees west. So what that means is 60 degrees west of north. And they sail for another 5 miles. So let's draw a diagram here. They go 10 miles. If they would have continued straight, but they don't continue straight, they go 60 degrees west of north. So they're going this way now. And that's 5 miles, but that angle in there is 60 degrees, and this distance now is 5 miles. And the question is asking us, what is their straight line distance from the port? So here's the port, and here's the ship. So we're looking for the distance from P to S. So let me see if I can draw in a straight line or something approximating a straight line. What I will need, of course, is this angle. And this is supplementary. If this is 60 degrees, this is 120 degrees. So I'm going to call this side PSC, and we're going to use the law of cosines. So how is the law of cosines going to work here? Law of cosines. Okay, Samantha says law of cosines indeed. Yeah, law of cosines is what we're looking at here, and this is where that angle is going to be important. 120 degrees here. Law of cosines, one of the versions we have is c squared is a squared plus b squared minus 2ab cosine c. So in this problem, angle C is opposite little c. Angle C is 120 degrees. I'm going to use that in that spot. Little a we'll call 5, and little b we'll call 10. These angles then, if this is A, this would be angle A here, and this would be angle B here, but I don't care. I don't need those. So let's go ahead and make our substitution. C squared equals A squared, 5 squared, plus B squared plus 10 squared, minus 2 times 5 times 10 times the cosine of 120 degrees. Continuing with our computation then, we get c squared is 25 plus 100 minus 10 times 10. 2 times 5 is 10 times 10 is 100. Cos 120. Now, let's think about cos 120. 60 degrees is a reference angle. It's the same as cos 60, but in the second quadrant. Cos 60 is a half, but in the second quadrant, cosine is negative. So cos 120 is negative 1/2. So we'll say c squared is 25 plus 100 minus 100. Cosine 120 is negative 1/2. Again, 120 is in quadrant 2. Reference angle is 60. Cos 60 is a half. What do I get here? I have c squared is 25 plus 100, 125. Minus 100 times minus a half would be plus 50. So we get c squared is 175. Which tells me that c implies, I need to say here, c is the square root of 175, which is root 25 times root 7, right? 7 quarters is $1.75. So if we simplify this, we're going to get that c is 5 times the square root of 7. C is 5 times the square root of 7. All righty then. We've got one more word problem to do on this test, and then we'll see if we are capable of doing that. So here is this question. So what does it say? A fire starts, and the water tower is 150 feet away from that fire. The water tower, ranger's tower, and the fire form a triangle. The water tower, the ranger's tower, and the fire form a triangle with a 97-degree angle at the water tower and a 34-degree angle at the ranger's tower. The rangers have to go to the water tower first, and then they have to go to the fire. So what does this question say? Find the distance from the ranger's tower to the water tower. So let's take a look at a picture. Ranger's tower is where? This is the ranger's tower down in this corner. And this is the fire. So we want to find the distance from the ranger's tower to the water tower, so that will be C. How close is the test in relation to the problems compared to the test we're taking tomorrow? That's a really good question. Remember, anything that we studied is fair for the exam. So there are some questions on this version of the exam that you won't see on the test tomorrow, and obviously there are some questions on the test tomorrow that are not on this version of the exam. We write new exams every semester, so you can take a look at the last 3 or 4 to get a feel for what these exams tend to look like. That should give you a pretty good idea. At least I hope it will. Anyway, how are we going to do this? I need to find this angle C, so I'll call that angle C opposite little c at the fire. And to get angle C, I know that the 3 angles have to add up to 180. So angle C will be 180 degrees minus 34 degrees minus 97 degrees. So if I do that, I believe that is 49 degrees. And I am looking for length C. Well, what I can say is I can say sine C over little c. I'm looking for little c. Now I know the angle C. Sine angle C over little c is, you'll notice I have 150 and 34 are opposite each other. Let me call that sine A over angle A. So sine C, that's sine of 49 degrees, over little c is what we're looking for, equals sine A, that's sine 34 degrees, over the thing opposite 34 degrees, which is 150. So keeping that in mind, multiplying both sides by 150c, I get 150 sine 49 equals c times sine 34. So if that's the case, divide both sides by sine 34. 150 sine 49 over sine 34 equals c. And on our exam, that's the best we can do. We can't go any beyond that because we need a calculator to get approximations for sine 49 and sine 34. So if the exam has a problem like this and asks you for an exact answer, that's about the best you can do. Now, that was the end of the test from fall 17, but I did notice that there were no triangle questions on that test. So let's quickly do a couple triangle questions just so I know you are confident with those concepts. So if I have a situation like this, let's say that this is 70 degrees. Let's say that this is 6. And let's say that this is 8. And I want to find the area of this triangle. So this is an SAS situation. If I have an SAS situation, how can we go ahead and find the area of the triangle? We recognize that area is 1/2 base times height. Now, the base and height are perpendicular to each other, so you're going to need to draw in a height for this triangle. So I'll go ahead and I'll do that. Boom, 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 boom. This is the height of the triangle. And I want to find the height of that triangle. Again, you don't have a graphing calculator, so you're going to have to do your best to figure out what that will be. So I can do that. I can recognize that if I just focus on this half of the triangle, I have a right triangle. That's 90 degrees. So that I can say that the sine of 70 is opposite over hypotenuse. I can say that the sine of 70 degrees is the height over 6. So 6 times the sine of 70 degrees is the height. Well, that's nice. But where do we go next after that? We recognize, as I set up here, that the area is 1/2 base times height. So I have area is 1/2 base. Base is 6. Oh, excuse me. Let me change that. Base is 8. Area is 1/2 times 8 times the height, which we said was 6 times sine 70. So 1/2 of 8 is 4 times 6 is 24. So the best answer I can give you is 24 times sine 70. Now that might be square inches, square feet, square meters, square units. Just want to emphasize the fact that we're dealing with square units when we do area. Michelle has a question for me. When given a triangle without definite knowledge that it's a right triangle, should we use the law of cosines to find a side? You can use law of cosines or you can use law of sines, right? So if it's an oblique triangle, it depends on what you have. If you have SSS or SAS, you have to use law of cosines. If you have ASA, SAA, you use law of sines. So yes, indeed, law of sines is used for oblique triangles. Law of cosines is used for oblique triangles. Let us do one more problem with area of triangles. We'll do an SSS this time. So if I have these sides, if I have, this is 4, and I have, this is 7, And I don't know, what does that look like it's about? It's a little bit less than 7. How about we make that one 6? This is an SSS case. We have all 3 sides. If you wanted to find an angle for this triangle, you would have to use law of cosines. But that's not the question I'm asking here. I'm asking us to find the area. Find the area. So to do that, I need to find the perimeter, and then I need to find the semi-perimeter. So the perimeter of this is 4 plus 6 plus 7, which is 17. So the semi-perimeter is 1/2 of the perimeter, which will be 17/2. So to do this, we're going to go ahead and use Heron's formula. Area is the square root of S times S minus A times S minus B times S minus C. It certainly would help to have a calculator, but the best I can do here is to say area is a semi-perimeter 17/2 times S minus A, 17/2 minus 4, times S minus B, 17/2 minus 6, times S minus C, 17/2 minus 7. With sufficient time and sufficient technology, we certainly could write that in a different sort of way. But that's it. I mean, that was the exam from fall of 2017. Plus, I added a couple area of triangle problems on the back end of that. I think we hit most of the behavioral objectives, though, in tonight's review. Most of the key ideas were covered. Now, obviously, the difficulty level can change from exam to exam, and there may indeed be some things that we missed here that'll be on your exam tomorrow. But I think this is a pretty good review. No discussion on Tuesday. That's right. We cancel the discussions the day after the exam. So I think that's a good idea. So I hope I can announce that tomorrow. But I want to just make sure, given the TA strike, that we're still good to cancel the discussion on Tuesday. All right. I hope you found this helpful. There will be teaching assistants, learning assistants, professors around tomorrow to help. I apologize for the craziness with the strike. We did our best to stay on topic during that time, but I certainly hope that we can handle that. Maria Borisic wants us to do one simplified problem. Maria, send me an email and I'll be happy to do that for you. How's that sound? All right. Thank you, friends. Triangles with no solution, there could be, or more than one solution. That's possible. But remember, those are kind of difficult to do when we don't have a calculator. So just kind of keep that in mind. All right. If you have any other questions, like I said, send me an email. I will be checking that shortly, and I'll do my best to write up solutions for you personally. Have a great night, and I will see you tomorrow.